this is such a great question. Let's take a look at it. So we want a free body diagram showing all the forces on the block. So I've got F1 here. I've got the weight pointing down here. I've got the friction force pointing left. And I've got the normal force pointing up. So those are the forces acting on the block. Now, I want to know the normal force exerted on this block. Let me actually split this F1 into components. So I'm going to have F1 cos theta going to the right, and I'm going to have F1 sine theta pointing up. So when I want to actually solve for the normal force, I'm going to have the normal plus F1 sine theta balances the weight. And so my normal force ends up being mg minus F1 sine theta. This is very similar to a multiple choice problem that we did before. Now, for us to actually end up getting mu, well, let's see how we can do that. So for part C, I know that F1 cosine theta acts against the friction, and the effect is that the mass accelerates at A1. So I can actually get the friction as F equals F1 cos theta minus MA1. And since I know this is the normal force, what I can do is I can divide F by N to get mu, and that's going to give me F1 cosine theta minus MA1 divided by mg minus F1 sine of theta 1. Awesome. Now for part D, we want to sketch the velocity and position as a function of time. What's funny is I know I have a constant acceleration, so what that means is my velocity graph looks like this, and my position graph is just a parabola like that. And then finally, there's going to be a big enough F1 that we almost lose contact with the ground. That's another way of saying that the normal force drops off to zero because the surface is barely touching the object. And so what that means is I'm going to end up actually simply getting there's no friction force. And so that tells me that F1 cosine theta is going to actually just end up equaling MA max. And so F1 cos theta divided by M is what A max is going to end up being. So that's it for the very first free response question.